All right, welcome back. Hi, kids. We're to find the direction of the magnetic field around a carrying wire, we're going to use the first right-hand rule. So this is going to be used to find the direction of the magnetic field around a current carrying wire. Now, just so you guys know, I'm going to say current carrying wire a lot in this unit, so I'm going to abbreviate that CCW for current carrying wire, okay? But first thing you guys have to be able to do is you have to hold your hand out like this. Okay, everybody do it. I'm waiting. Everybody do it. Okay, everybody do it. Okay. Do you see how one of them makes an L when you do this? That's your left hand. You're not going to use your left hand to do the right hand rule. If you use your left hand, you'll get the wrong answer. If you use the right hand, you will get the right answer. For people like me who can write left-handed, if you're really gifted like me, you can write left-handed. Well, you can write and do the right-hand rule at the same time. If you are, for those poor schmucks that are right-handed, you're going to have to take your pen, put it down, do the right-hand rule, pick your pen back up, and write your answer. Man, you are going to lose precious seconds. Sorry, blame your parents, okay? But I want to show you guys how to do this. When we are doing this, now remember, okay, actually, let me do this first. Remember, let's say this is my wire, and I have current flowing in it, okay? The magnetic field, we know, is circular, going around that wire. Okay, it's looping around. It's kind of like, it'd be like going like this. You'd go, okay, it's looping around like this. It's looping around like this. Okay. The problem is I have a three-dimensional thing here. I have a three-dimensional thing, and I have a two-dimensional sheet of paper, so I'm trying to show a three-dimensional thing on a two-dimensional sheet of paper. So that means on this side, the magnetic field is actually coming out this way, coming out of the board, coming towards you guys. So I need to be able to represent that. And on this side, it's coming and going into the board. It's going away from you guys, into the board. So we need to be able to represent out of the board, into the board. Well, magnetic field is a vector. Well, what does that mean? That means you have to draw your F and arrows, okay? So we got to draw our F and arrows. So if I have this coming out of the board, if I have an arrow that I'm shooting directly out at you, what's going to happen is you're going to see the point coming right at you, and the point is going to be a dot. So a dot is going to represent, or multiple dots, is going to represent coming out of the page, or in this case, the board. Okay? Whereas if I take, here I am behind you, okay? And I'm going to fire an arrow away from you, you're going to see the back of the arrow. Well, the back of the arrow is going to be an X, where the feathers are. So an X is going to represent into the page, or in this case, the board. Okay, so if I was to draw this, I could really draw this, where on this side you would have dots, and on this side you would have X's. And what that means is that the magnetic field is starting here, coming out, looping around, and going in. Coming out, looping around, and going in. Well, how do we know that? That's where the first right-hand rule is going to come in. But you guys have to know this first, so hopefully everybody's good there. Okay, so first right-hand rule, when we do this, your thumb points in the direction of the current. Okay, and remember, it is your, let me get this so you can actually see it. It is your right thumb. Your fingers curl in the direction of the magnetic field. This should be easy to remember. Okay, so you guys, you're not going to do this. You're not going to make a fist. Okay, you're just going to curl your hands. And this should be easy to remember because there is only one wire, okay? You only have one thumb on your hand, and your fingers, okay, there are multiple magnetic field lines, and you have more than one finger, so your fingers curl like this. Now, unless you're some kind of freak of nature, your fingers can only curl one way, and that's going to be how the magnetic field is going to loop around. So if we do this, if I go to my example, okay, that I just did, okay, everybody do this with me. Thumbs up, everybody. I'm waiting. Use your right hand there. Okay, right hand. And then if you see on this side, my fingers are curling and they're going into the page. Well, how do I show that? Into the page. Oh yeah, that's an arrow going in like this. So it'd be X's on this side. Okay? Now it's going to loop around. On this side, my fingers are looping out of the page. Again, you guys are all trying this. Don't just sit there like a lump. Okay, on this page, this side, it's going to be dots. So around that current carrying wire, that's what the magnetic field would look like. Okay, out of the page, into the page. Okay, I'm going to give you guys, I want you guys to try a couple more examples. And so I want you guys to try this one, try that one, and then try that one right there. So try those 3 examples. All right, bye kids.